chemistry?
I like biology more.
Biology. Me also like biology. No one loves chemistry?
No, teacher, we all love chemistry. I love science.
Yes, all of science is very enjoyable and it's very nice. Okay. Today we will take chemistry. I will give you a small introduction about chemistry. Okay, are you ready?
Yes.
I want you to enjoy your lesson, not only to keep the information and study, but I want you to enjoy it. Okay.
Okay.
Okay. Let's start. Here we go. Can you see the screen now?
No. Till now.
It's
Yeah,
okay.
we can see it right now.
Yes, you can see it.
Okay.
By now, we are aware of the difference between elements, compounds, and mixtures. Do you remember the differences? Mixtures are like food items that we consume.
Okay. Let me ask you first. Do you know the difference between elements and compounds and mixtures?
Yes, teacher.
Okay. Tell me your name and tell me what you know about the difference between them. Malak, tell me.
The element, it's made up of like, it's the purest, simplest, pure. And it
Yes,
can be
the
analyzed
pure
into,
form of an element. Excellent. Yes.
the compounds, it's like made up of one more, it's a combination.
Yes.
Made up of more than one element.
Excellent.
And in the mixture, we have lots of elements, but they are not combined together with a bond.
Perfect.
But in the
Malak,
compound,
perfect.
it's like a solution. It is a mix. It's a mixture, but with bonds.
Yes, that is very, very good explanation. Excellent. Okay, so I want someone to answer. Tell me, in which one we can remove some of the components? Can I remove things from the compound or I can remove from a mixture? I want someone else who can tell me. Now I have a mixture and I have a compound. Which one I can remove elements or I can remove any component from it?
We can move from mixture.
Compounds?
From mixtures. Excellent. Who said mixture?
Me, Radwa.
Radwa. Excellent,
Why?
Radwa. I will tell you why, Basant. Because as Malak said, the mixtures, the components or the elements, they are not connected together. They are not connected. But in the compound, there is a bond which attach them together. Now you can see and tell me, look here, listen to the video. Wait.
They contain everything in proportion that we desire. We can add or remove a substance according to our need. Compounds, on the other hand, are those which have substances in fixed proportion. So if you change the proportion of substances, it will affect the compound and render it changed. For instance, if you remove even one hydrogen from H2O, that is water, the composition changes and water as a compound does not exist. Thus, fixed proportion is a must in compounds. Lastly, we have the elements. These are the purest forms of any known substance. They are composed of only the same.
Okay, so Basant, as you see here, in the mixtures, we can add or remove any component, any proportion. And it's, for example, the fruit salad or any salad. We can add some fruits or some vegetables, or we can remove it from it. But if we are talking about compounds, the water, for example, it's H2O. I have 2 hydrogen and 1 oxygen. So if I remove one H, can the component or can the compound be water as it is?
No.
No.
No. So that's why we cannot remove any element or any component in the compound. But in the mixture, we can add or remove with any proportion. So now, did you understand the difference between mixtures and compounds?
Yes.
Yes.
Okay.
Yes.
And as we see here, the elements, it is the purest form. It is very pure. It's only one thing. That's
Type of
complete.
atoms. There are neither proportions nor random mixing of substances. So can we say that compounds and mixtures are made up of elements? Absolutely. So in nature, it implies that elements are the basic forms of every material that we find around. And hence, in order to study every substance around us, we need to begin with studying the various elements. So where do we begin? Maybe the reactivity or maybe the physical properties first, right? I'm asking if we can study the reactivity and physical properties of each of the elements. Is that feasible? Well, all these would have been valid only if the elements would be few in numbers. Do you know the number of elements that exist? Astonishingly, the number of elements that we find naturally occurring is 98, while the total number of elements known to mankind is 118.
Okay, so here let's talk about the elements. Now we know that we have elements, we have compounds, and we have mixtures. The elements make the compounds and the elements make mixtures. So now we want to know more about these elements. In all of the world, we have total elements, 118 elements. 98 of them are natural. Natural means that we find it in the nature. Some elements, the man do them. So we have natural elements and manufactured elements. So the total elements now in the world are 118. Do you have any questions?
No, teacher.
Okay. So how can we study all of these elements? Are we going to get each element and study and know everything about it individually, or we have to organize all of these elements?
We have to organize.
Yes, we have to organize all of these elements and get all the elements which have the same properties and put them together. Another elements which are different, I move them and put it in another position. And I have to organize each group of elements so I can study and know everything about them. Okay, so anyone can tell me how can we organize these elements?
Yes.
Tell me, Malak.
By like putting the elements that have the same things under each other.
Okay.
Like with the elements which had the same melting point, boiling point, anything of these.
Perfect.
I can put them under each other and also on.
Okay, excellent, Malak. Anyone else can tell me how?
Yes, can I answer?
Yes, Abdurrahman, come on.
We can also sort them by their atomic weight.
Excellent, perfect. So the one with the same atomic weight or near atomic weight, we will put them together, right?
Yes, teacher. Teacher, can I add something?
Yes.
Also, I can like put them into groups.
Perfect, Malak, perfect. Excellent, Malak and Abdurrahman. Okay, let's complete here.
How do we study each element individually for all its properties? Looking at the number of elements that exist, I don't think it would be convenient to pick every element individually and study all the properties, right? Imagine you have to organize the kitchen. You will not place any vessel or eatable randomly anywhere. You will organize the shelves and refrigerator in the most convenient way which is suitable for your needs. Similarly, for studying so many elements, we need to organize them appropriately. And organization begins with arrangement. Yes, arranging the various elements is the first step towards understanding their properties. And arrangement is possible only if we categorize them, right? This is how we organize the elements. And this process of categorization helps us study the elements with ease. In other words, we've classified the elements here. Classification of elements is categorizing the various elements into groups based on similarities and differences in their properties. The classification system helps us in grouping the various elements into categories, which we refer to as the periods. Hence, the system is also referred to as the periodic classification of elements. Let's get to know how periodic classification was carried out in the early days of emerging.
Okay, so as you said here, that we are going to organize and to arrange all of the elements and put them in groups. So as Malik said, we are going, or as Abdurrahman said, we are going to put them into groups. Here we have this group of elements, and here we have another group. Here we have another group. Each group has similarities in their properties. And also the different elements, we're going to put them in a different position. So here in this one on the left, they have the same properties. Here on the right, another group with different property from this one, but they are similar within each other. So we are going to make classification, periodic classification of elements. We are going to classify the elements into periods and groups. Is that clear and easy?
Yes, teacher.
Anyone have any question?
Thank you.
Okay, so now we want to know how scientists organize and classify all of these elements into a group. We have 3 scientists which organize and arrange the elements which we have in the nature. Let me complete this video for you first.
To know how periodic classification was carried out in the early days of emerging chemistry when not many elements were known to people. In the upcoming videos, we will understand the various classification systems put forth by the different legendary personalities.
Okay, now we are going to take the 3 scientists which organize the elements. Here we have it. We have the first one was called Mendeleev's. So the scientists arrange the elements into a table. They put it in a table. So we have 3 tables. The first one was for Mendeleev's periodic table. Number 2 was for Moseley's periodic table. Number 3 was modern periodic table. The modern one, this is the last one, which now all of the scientists use it to classify and know more about elements. So now we have Mendeleev, Moseley, and modern. We can call it the 3M. We have 3M.
Mendeleev,
Yes, Mendeleev,
Moseley,
Moseley,
and
and modern. Excellent. Okay, who else can tell me the 3M, the 3 scientists or the 3 attempts which we classify elements? I want someone else. Where is Adam, for example? Adam? Lujain, Mirna, Muhammad, anyone?
Yes, teacher, I can answer it.
You are Mirna?
Yes.
Excellent, Mirna. Tell me, Mirna, who are or what are the most 3 important atoms?
Atoms?
Yes, for classifying the periodic table or classifying the elements.
We have to use the 7 levels of energy.
Okay, but first I want you to tell me
I
the
didn't
3
understand the question, teacher. What does mean the 3 atoms?
the 3 ways or the 3 scientists which classify the elements. Who are them? Who are the 3 scientists?
Can I say them?
Scientists. I heard it atoms. Mendeleev,
Okay.
Moseley, and Mendeleev, Moseley, and
the modern?
modern periodic table.
Yes, excellent. So you have Mendeleev, Moseley, and modern. Excellent, Marina, excellent. Okay, now we can start by the first one, the first M, Mendeleev. Mendeleev was a Russian scientist, and he was the first one to classify elements. So it is the first real periodic table for classifying elements. So which scientist is the first one to classify elements?
Mendeleev.
Mendeleev. Excellent, Basant. Excellent, Malik. Okay, at this time, when Mendeleev classified the elements, it was in 1871, long time ago. At this time, only 67 elements were known. So at Mendeleev time, we only know 67 elements. So Mendeleev, he got the 67 elements and he started to classify them. Let's see how he made this. Mendeleev, he got 67 chords. He got some chords, 67, one. Each chord represents an element. So as we saw in the video, we have many elements. They are randomly. So he got all of these elements and he made 67 chords for each element. Each element has a symbol of a chord. On each chord, he writes the symbol of the element and he writes the atomic weight, the weight of the atom. And also he writes on the chord its important properties like the boiling point, melting point, density, the formula of oxide, and some other properties. So again, on each chord, he writes how many things? 3 things. He writes how many things on each chord?
3 things.
What are they?
The atomic weight.
Tell me, Noor.
He put the symbol of each element.
Yes.
And the atomic weight.
Excellent.
And the most important properties of the element. For example, the melting point and the boiling point and this thing, the density. Yeah.
Density. Excellent, Noor. Excellent.
Teacher, I have a question.
Yes, for sure. Ask.
What is the meaning of the formula of the oxide?
The formula of the oxide, it is how can this element make an oxide in another compound. Some elements make compound. The element make another compound. This compound, it can be oxide or something else. For the oxide, this element have to come with a ratio, a different ratio for each oxide. Okay, we will take it later, okay?
Okay.
So the formula of oxide, it's how the element ratio of this element make a compound, okay?
Okay.
Any more questions?
Teacher, you mean it makes a compound with oxygen?
Yes.
Okay.
Okay.
Thanks,
So
teacher.
can you tell me, for example, do you know any symbol for any element? Anyone know any symbol for any element?
Yes,
Okay.
teacher, I know. Sodium.
Sodium,
Na.
Na, excellent. So if we are talking about the element sodium, Mendeleev come and he makes a chord. He get a chord like this. And he start to write first the symbol, which is Na. Then down here he write the atomic weight. Here he write the atomic weight. And at the back of the chord, he writes some of the properties. For example, sodium is metal or non-metal? Can anyone know?
Metal.
Metal, excellent. So at the back, he writes that the sodium, it's a metal. And he finds the boiling point and the melting point and the density, and he writes each of the information for each element. So that is how he designed the chords. For each of 67 elements, he make a chord with the symbol, atomic weight, and properties. Okay?
Okay.
Okay. Then he make what? He arrange the elements of similar properties. So he arrange according to the properties. He arranged elements of similar properties in a vertical column, which were known later as groups. So he gets some elements with the same properties, and he starts to put them in a vertical column like this. Here's an element, another element with same property, another element with same property, another element with same property, like this. Then he find a different element, he put it in another group, and he put with it another elements which have the same property as the first one. So he arranged element in a vertical column known as group. He also classified the elements of each main group into two subgroups. Okay, to know about this, I want to show you something.
Teacher,
Yes?
Teacher, can I
I
answer?
didn't.
Who is talking? You didn't what?